Hey everyone, so today we are tackling the singleton pattern, but I wanted to take a completely different approach than what you are probably used to saying on YouTube. Instead of just saying, hey, here's the singleton code and memorize this, I wanted to show you guys why this pattern even exists in the first place. When I was learning LLD, I would watch these tutorials and get so frustrated because they just threw these abstract concepts at me. And if you only memorize the final solution the second an interviewer interrupts your flow or changes the requirements, you are completely lost. So coming to the structure of these videos, I wanted to keep it very simple. I'll give you a problem statement. You try to solve it. Don't worry about any fancy pattern solution. Just write the absolute most basic, most naive code you can think of. From there on, we'll figure it out where it breaks and we'll keep adding to it until we arrive at the perfect design pattern solution. Just a heads up, there are three quick ground rules before we start. First, I'll be using C++, but the underlying principle which I will share with you guys are exact same in every language. There may be some keywords which are here and there, but the overall concept, it's completely same in every language. Second, there is no hard and fast rule that a problem can only be solved by one of the specific patterns. Usually what happens in production, there are multiple patterns that are being used together. But for now, we'll keep it simple and focus only on a single pattern at a time. There's absolutely no need to memorize all 23 design patterns. We're going to just focus on the most important 8 to 10 patterns that are actually asked in 99% of the interviews. All right, with that out of the way, let's look at today's problem. So starting up with the question, I'll be copy pasting the question over here. The question says, let me indent it first. Yes, the question for you guys is you have to design an absolutely basic logger. It just consoles out the message you send it and can be used by other services in code. No need to make it fancy. No need to differentiate it on based on warning, log, or error. Just simply it should accept a string, console that message, whatever you are sending it to that logger, and all the other services can use your logger as part of your code. So I'll give you guys 2-3 minutes to think about the solution. Try to think of a solution, make class, make function in it, try to implement it. Just have to be absolutely basic, nothing fancy. Think about it, pause the video here, think about it. If you want to code, you can code. I'll be coding it with you guys. Yep. So I think you might have thought of a solution now. Before jumping onto the solution, let us write requirements for this. So the requirements were just simply log out, my bad. Simply log or console out the message which is being passed to this logger service. Right. I'll open up my VS Code and create a class, create a method in it. Defining a class for logger, let's say I give it name as logger. Making a public function in it, let's say we call it as log message. Right, it accepts a string and we just have to console out that string, making it a little bit fancy. Yep. Now in my main function, I can simply make an object of this class, call it L1, and pass a log message in it. This is my very first log. Similarly, I can create another object and send another message. This is my second log. And this is somewhat mimicking. If I had two different services, service 1 and service 2, they would use my logger like this. Right. Running this code. Yeah. So as we can see, clearly the input which we sent is being consoled out. So you might think I gave you guys a problem statement. If you wrote this code, it completely satisfied the problem statement you were given. It completely fulfills the requirement that you guys were given. And this is, working. Let's call this as service A. Sorry, service B. Let's call this as service A. And it's completely fine. We were able to log this message and log this message. But in actuality, this log message is never like this. It's usually file operations are being performed over here. And in those file operations, logs are kept on being added and added. And there may be multiple processes which are accessing this piece of code and writing again and again to the same file for keeping a global log. So what's the issue right now? The issue would be when multiple services are creating an object and writing to the same file, which we are mimicking over here. The OS might throw an error, which would be that multiple processes cannot perform a write operation on the same file at the same time. By this, what I mean is, I'll explain you guys with an example. Let's say this is my file. This is my file in which I'm writing things. I have a service A, a service B, and a service C. Let's call it service M. This is my service A. This is my service B. And let this be service M. Right. Looking at our code, what these services will do, they'll create objects, individual objects for logger class. This will be L1. Let's call it L2. This will be LN. They'll be attached to these services. It may attach them for you. And finally, they will be all of these objects will be writing to the same file. So what happens? OS does not let you write to a same file when multiple objects are being created. OS says you can't write to the same file at the same time from different objects. OS will throw an error. It will not allow this process, this part to happen. It will just throw an error and you won't be able to write anything in it. This was the first problem, that OS does not allow you to write into a file with different objects at the same time. The second problem would be the concurrency problem. Suppose this service is trying to write to this file, and then this service is also trying to write to the same file at the same time. There might be a situation where this service is trying to write, let's call it hello, and this service might try to write word. Assuming OS doesn't throw an error at present, a situation can arise where it's HE from hello, WO from world, then again LL from hello, then RLD from world, and then O, my bad, O from again hello. So you'll be overwriting in the same file, and your logs will not make sense at all. So over here we have two big problems. We have two issues. OS is not allowing us to write to the same file at the same time via different objects. Right. The second is concurrency issue. This happens in multi-threaded environments, which is usually every environment. You don't have a single threaded environment anywhere. Let's try to tackle the first problem. So over here, it's the OS is not allowing us to write to the same file at the same time via different objects. So what if instead of making all these objects, we make a single object? Using that single object, we write to the file and allocate that single object to different processes, whoever is writing at that file. What I mean from what I just said, I'll explain you guys with the diagram. Let's just copy this whole. Cool. And I'll paste it over here. I'll delete all of these. What I was saying to you guys, let's create an object, call it as only L1 logger. This object is responsible for communicating with this file. No other object can create, no other object can, access this file or communicate with this file. So now what our structure would look like, all these services would get this object, and using this object, they'll try to now write to this file. I hope you guys are following me till this point. If not, let me know in the comment section down below. But yeah, let's get back to this problem. So what I've done, instead of creating all these separate objects, which are present over here, I just created a single object, and all the services which are there in my code uses the single object and write to this file. And cool. Now, technically speaking, we should allow this. The first issue should be gone. If I'm writing to this file by a single object, even though this happens at the same time by different services, but since this is a single object and it has only one connection and only one object is making changes to this file, OS should not throw error. Over here, the issue was OS was throwing error because we had multiple different objects which are writing to the same file. Now only one object is writing to this file. So first issue is clear, right? This is handled. We'll come to this multi-threaded part later. Let's try to code this part up. Cool. But how to handle the situation of creating only a single object? We know we can create through static, but if we give each of these services access to creating object of this class, they'll be able to create it. We have to somehow control so that none of the classes, or you can say services outside of this class, are able to create its object. What we'll do, we'll declare the constructor of this class as private. That way we can handle that no one outside of this class can create its object, right? Let's go ahead and do that. Yep. So as you can see, I've created this object logger inside of the private section of the class. It's throwing errors that this part of the code is not accessible. Now we can't create objects like this. What we need to do is we'll look at the basics of this class and see anything which is inside the private section of the class is only accessible inside of the class. So what if we create an object inside of this class and then return its value so that services outside of this class can access that object? Confused? If I was hearing it for the first time, I think I would also pretty much get confused. But yeah, let's code it and then see. What I told you was to create a method. Let's say we call it as for now void. Give it as a name as get instance. Inside of this, we create a static object of this class logger and call it as one and only instance, and return this one and only instance. My bad. I was instead of this word, I would have to return it as logger. This is for referential memory allocation in C++. I'm returning the reference of this object, so I'm returning using the and sign. So now we know if services outside of this class calls this get instance, they'll be able to have this one and only instance, and we'll be able to use this single instance throughout our code base. We have ensured no other class can make object of this class logger, as we have declared the method, the constructor in private section of the class. But if we look at this method, do you really think this method can be accessed outside of the class? Usually you need a object of this class to access this method, right? So for this, we have to make this method as static too, so that it's accessible outside of the class. Now, if we look at this code and go ahead and be like, hey, I am accessing the reference of this logger class, a reference of the object of this logger class, and I'm calling it as L1. I need get instance method, which is a static method in your class, and I need whatever it is returning back to me. So I'll have the reference of this one and only instance in my this variable. I can just go ahead and simply L1 dot log message. This is my first log message, and done. So what we did was we made the constructor of this class as private so that no one is able to create object of this class logger. But since we need one instance to be there, we created it as static inside of this class and return that reference to the outside world. We're saying, hey, you can call this get instance. It will return a logger to you, and you can use that object to call every other method which are publicly available in this class. So essentially, this part is done. There is one problem right now. If you can think of that problem, do think, try to think. We've made sure no one is able to create method of this class, right? But what if another class comes? I say it as logger 2, and it tries to inherit logger. It will be able to do so, right? This is still allowed. So essentially, whenever someone is trying to create object of logger 2, it will first create object of this logger, and then it will create object of this logger 2. When it will try to create the object of logger, it will throw an error because our constructor for this class is in private section. So this is handled. We'll not be able to create an object, but it will always constantly throw an error. To solve this issue, we have to tell, you can't inherit from a class whose constructor we have marked as private. So for this, we have this keyword as final. This is something which is exclusive to C++. You might find something very different in other languages. I think in C# we have sealed as a keyword there. I worked on C sharp, so yeah, I know about that. Yeah. So every other languages would have some keyword related to this. C sharp has sealed, C++ has final, Java would have something else. Look it up. So now it's throwing this error. It's throwing a final class type cannot be used as a base class. None. At this point, we cannot create object for this class. We cannot inherit this class, and we are pretty much good. We have ensured that this class is not able to create an object. If we look at this code, this is pretty much the code for a singleton pattern. Yes, you heard it right. This is the code that you need for a singleton pattern. That's it. These 4 or 5 lines is all you need for a singleton pattern. But since we are dealing in C++, there are some things which are not handled over here, but it would be handled in other languages. Since C++ gives us a low level control, so we would need to handle some basic things, which include the copy constructor as well as the assignment operator. By them, what I mean is what if I do something like this? L2 is equals to logger get instance, right? And then I do L1 L1 is equals to L2. You might think this is absolutely fine. This is L1 is a referential type, L2 is a referential type. We are putting L2's value in L1 since they're same value. It should not be of an issue. But no, what internally it does, it creates a temporary object and then it copies the value to L1. So for that, we would need to explicitly handle both the assignment operator as well as the copy constructor so that no one is able to, bypass what we have done over here. Let's do this. I'll first create the copy constructor and say, if someone is trying to copy, just delete it. Let it be like that only. And for this, what I will do with operator to assignment operator, my bad, is I'll tell it whenever it's being used, I don't want it, and just throw an error. Right. These two things are pretty exclusive for C++. Other languages, in other languages, you don't need them. Apart from this, these two lines, this was your pretty much final thing. You don't have to worry about anything. This was your singleton class done. Singleton design pattern, and this is how you handle everything if you're given a situation where you have to design a singleton pattern. I'll just add those lines back. Yeah. So anyone who's writing code in C++, you need all of these three things to be under private. You do need them. There's a workaround. If you don't include them, there's a situation where you can create an object using these copy constructor. By default, if you don't define these copy constructor, the class makes them in by default in public section of the code. So you have to define them in private section. Done with this. Now coming to the second situation. The second situation says that what if this file is trying to write hello to this, this service is trying to write hello to this file, and at the same time, this service is also trying to write world to this file. We might end up with something which we saw earlier, which would look something like this. Right. Hello and then world. This is completely jumbled. This is of no use to us. So how to ensure that only a single object can write at a single time? This is something which is totally not related to singleton pattern. But if you want something in detail, how things work, how you handle concurrency issues, this would be a plus point. Usually you can impress your interviewer with these topics if you know them. So what I'll do is I'll copy this again. I'll paste it over here. I'll again remove these, right? Shift this a little bit back, shift this to a little bit right, and eliminate this. To handle these concurrency issues, there's a pretty straightforward solution to this. We introduce mutex locks, or let's not go fancy, we'll introduce locks. Locks are very simple. You don't have to worry about these. It's simply like a door. You have a lock on it. You need a key to open that lock. As soon as someone enters the house, or essentially what you call it as critical section of the code, you lock it. As soon as that process or thread leaves the critical section of the code, you unlock it. Then the next thread comes, acquires the key, goes into the critical section of the code, locks again, and when it's done, it unlocks the lock. So what it looks, I'll show you. Assume this is the lock in front of the critical section of our code. Critical section of our code would be this log message. This is being used by every other service. So this is the lock which we are going to introduce before our critical section of the code. And we would have a key for this lock. Assume this is the key. I'll remove this and just simply mark it as key. Whoever has this key will be able to go into our critical section and perform action over there. And as soon as they're done with their task, they'll open the lock, leave the key over here, and go back. And the next process will come, pick up the key, go into the critical section, lock from inside. This will be locked so that no one can enter this lock. Be done with their task, unlock this lock, and go out. So every service would first come to this lock and see if it's open or not. Let's suppose these two services at present are coming and they want to write, the first service want to write hello and the second service wants to write word. So they both see that the lock is open. Whoever reaches first will acquire the key. Let's say key was acquired by service I. This key was acquired by this service. So this service acquired the key, went into the critical section. It was assigned with some task. It was logging functionality. It wrote hello to this file. While it was writing hello to this file, what we observed was service B had no entry over here. It saw there is no key present. It's locked right now. And this service cannot enter this lock right. So it has to wait. So process has to wait. This process will be waiting over here. It's an asynchronous process. This process will be doing some other thing. As soon as the key is available, OS will let it know and it will come back up. So let's say this part is done. This hello part is written. And all this whatever we were doing over here, it's finished, and SA comes, unlocks this and puts the key over here and just goes back. Now SB comes, service B comes and sees that, oh hey, the lock is open right now and the key is present over here. I can acquire the key, go inside the critical section, check everything, perform actions, and just simply log whatever I have to write. And finally, when the process or when the work is done, I'll unlock this lock, put the key over here, and go back to where I came from. It's pretty simple. So by introducing this lock, we ensure that only one service can write to this file at a time. So if you look at this issue, where the concurrency issue was there, it's easily handled right now. Let's go ahead and now code it. So for introducing locks, there's a very famous lock called the mutex lock. If you want to study about this, you can go ahead and study. Or let me know if you want videos for this too. I'll be pretty happy to make one for you guys. Let's call this as logger lock. Right. Then I'll simply use this logger lock dot lock. And while the file operations are done, I'll just simply call it as unlock. This is done. Like I told you, introduce a lock. This was the critical section of our code. Lock it. As soon as things are done, unlock it. Make sure this lock is at the starting of the critical section and this unlock happens. Now there's one issue over here. If we use the standard lock and unlock, what if a service A acquires this lock, performs this file operation and throws an error? It will go out of the scope. It has already acquired a lock, but when an error is thrown, it will directly go out of the scope. So this line will never run and it will never unlock the lock which has been acquired. So this is an issue, which is, when you are trying to lock and unlock on your own, we usually avoid this. Instead of this, we introduce a lock guard. This handles locking mechanism and unlocking mechanism on its own. As soon as the scope goes out of bound, it will unlock it. And we don't have to worry about locking and unlocking. We just have to tell, hey, lock guard, I want to lock this logger lock over here. So if we look at our code, we have made sure this lock guard is now locking and unlocking on its own. If it throws error, we are 100% sure this will be unlocked. And essentially, we have solved our two problems. From the absolute basic class, we were first able to implement this our naive approach. We then saw what were the issues, why we had to increase from our basic solution, from our naive solution to a much better solution, which included a singleton pattern, where we had to create this a single object. And then in advance of that singleton pattern, we were able to handle concurrency issues too. So this was something a little bit extra. This is absolutely not a part of singleton pattern, but yeah, this is something which I found out very interesting while I was going through the singleton pattern. Oh, hey, you can handle the situation through singleton pattern, and you can learn this thing which we usually miss out. I think I covered everything in the singleton pattern. So every service which has to call this logger, will just simply able to call this logger like this. I'll call this as L2 get instant. No, my bad. Logger 2, L2.log message. This is my very first. This is my second message. And then I'll run this code. See, yeah, this is my very first log message. This is my second log message. Really memorize the design pattern. You just have to start from the very basic, build up your solution, what's the issue with it, and tackle the situation one at a time. If this video helped clear up your low-level design for you, hit the like button, subscribe so you don't miss the next one. Let me know in the comment section which design pattern or concept you want to tackle me next. Keep coding. I'll see you in the next video.